Hey guys, so today you all are going to be learning about volume of prisms. It's a little bit different than surface area. So with volume of prisms, you need to figure out what is the base of the figure that you're looking at, find the area of the base, and multiply it by the height of the prism. So if we were looking at this rectangle right here in this picture, the area, this is the base that it's sitting on, so we would find the area of the base and then multiply it by the height of the prism. If we were to look at this triangular prism, we would find the area only of one triangle. So with surface area, you have to use two triangles, but with volume, you only have to use one triangle. So you would find the area of this base of the one triangle and then multiply it by the height of the prism. So let's go ahead and look at example 1, which is a rectangular prism. So the base is 4 feet by 3 feet. So we would take the base and multiply 4 times 3, which gives us 12. Now we're going to multiply it by the height of the prism, which is 5 feet. Then we would multiply the two together. 12 times 5 equals 60 feet. Now, since we are technically multiplying 3 measurements together, 4 times 3 times 5, volume is given in cubic measurements. So with area, we always say squared. With volume, this is going to be 60 feet cubed. Let's look at example 2. Here is a triangular prism. Now this one's easy to see because it's already standing on its base. So the height is easy to pick out because it is standing on its base, which is the triangle. So the height of the prism is 9. If a triangular prism is actually resting on one of the rectangles, then to determine the height, you would have to flip it over to stand it on a triangle to see what the height would be. So let's work with the triangle first, which the base of the triangle is 10. The height of the triangle is 1/2. So formula for volume is the area of one base times the height of the prism. So remember, unlike surface area where you need both triangles, with volume, you're only going to need one. So it's going to be 1/2 times the base, which is 10, times the height, which is 6. So half of 60 is 30. Now, the height of the prism is 9 centimeters tall, so we're going to take 30 times 9, and our total volume is 270 centimeters cubed. All right, if we move on to example 3, this is a composite figure. When we use surface area and composite figures, we always had to worry about surfaces that were exposed or not exposed. You do not have to worry about that when finding volume. You just find the volume of the top piece, find the volume of the bottom piece, and then add the two together. Now, this is a triangular prism. The top part is a triangular prism, but it is not sitting on a triangle as the base. So this is where I was talking about where you would have to imagine flipping it over on the triangle to determine the height. So if I were to actually flip this top roof over to where it was standing on top of a triangle, the height of the prism would actually be 12 feet, which is parallel to this line right here. So first I have to find the area of the base. So this is just the top part that I'm working on. So the base of the triangle, which is right here, is parallel to 8 feet. So I'm going to do 1/2 times 8. The height of the triangle is right here, which is 2. So this is 16, and 1/2 of 16 is 8. So now that's the area of the base times the height of the prism, and that is 12. So I'm going to take 8 times 12, and I get 96 feet cubed. Now that's just for the top. So now I need to work on just finding the bottom piece. So I'm going to kind of erase all this. So the bottom piece, the area is 12 by 8. So that's the area of the bottom, 12 times 8, which is 96. And then I need to take the height of the prism, which is right here, and that is 7 feet. So the height of just the rectangular prism. We're not including the top part. So we're just looking at the bottom piece, and the bottom piece is 7 feet tall. So now we would take 96 times the height, which is 7, and we get a total of 672 feet cubed. Now, just like surface area with a composite figure, you then take your two measurements and add them together. So if I take 672 plus 96, I should get a total volume of 768 feet cubed. All right, moving on to example 4. Now this one, if you notice, this is a singular shape, so it's not composite, and it is already sitting on its base. It's a triangular prism. It's already sitting on its base, so we do not have to imagine flipping it to find the height of the prism. So the height of the prism is right here. It's 4 centimeters tall. We need to work on finding first the area of the base. Now if you notice with this one, it's 3 centimeters on this half and 3 centimeters on this half. So really we need to add 3 plus 3 to give us 6, which would be the total measurement of the base here. So for the triangle, it's going to be 1/2 times the height of 2 times 6, which is the total measurement of the 3 plus the 3. So 2 times 6 is 12, and 1/2 of 12 is 6. So that is the area of the base, and then we take, remember, area of base times height gives us the volume. So our area of the base times the height, and we get a total volume of 24 centimeters cubed. All right, moving on. Here is example 5, another triangular prism. Now this one is not sitting on the triangle face. So you would have to imagine if you flipped it over to where the 6 was now on the bottom, this 8 would actually be the height of your prism. So the 8 is the height of the prism. So first find the area of the base, because volume is area of the base times height. So we're going to take 1/2 times 6 times 10. 6 times 10 is 60. Half of 60 is 30. So now we're going to take 30, the area of the base, times 8, the height of the prism, and we get 244 millimeters cubed. All right, example 6. Again, this is a composite figure. Remember, you do not have to worry about whether surfaces are exposed or not. You just find the volume of each individual piece. Now, I think I cut off when I was screenshotting this over some other information with the dimensions, because really you can't solve this without knowing some other pieces. So I'm just going to kind of fill these in here. We're going to say that this measurement right here for this cube is 12. All of these lines going off the bottom are 20 inches and then 12 high. So technically it's not really a cube because it has two different sides. This one we're going to say has a length of 24 with a width of 20 and again a height of 12. And then this is 12 by 36 by 20. So the top cube right here would be 12 times 20, which is the base, and then we're going to multiply it by 12, which is the height of the prism. And so when we get that, hold on, I'm pulling out my calculator because this one I didn't pre-do. So 12 times 20 times 12, this one would be 2,880 inches. So the bottom one is going to be the base of 24 times that width of 20 times the height of 12. So when we multiply this out, we get 5,760 inches cubed. And then so the last one, we're going to multiply 12 times 36 times 20, and we get 8,640. So then you have to go back and add all of these up. So 2,880 plus 5,760 plus 8,640, and we get a total volume of 17,280 inches cubed. Wow, that's a lot of inches right there. All right, example 7. This is a pyramid. So same thing, find the area of the base. So the area of a base for the pyramid is not the triangle. The base is actually the square. In surface area, we would never use the square of a pyramid when it was on top of another figure because it wasn't exposed. But with volume, we need to use that. So the square, the measurements for the bottom of the square is 15 by 15, which is 225. So this is just the top part. The base is 225. Again, I got that by multiplying 15 by 15. The height of the pyramid is indicated right here by this 8-inch line. So I'm going to take 225 and multiply it by 8, and I get a total volume for the top of 1,800 inches cubed. So now I have to work on the bottom piece. So I'm going to take 15 by 15, which again is 225, but the height of the rectangular prism is 10. So 225 times 10, and we have 2,250 inches cubed. So then take that and add it to the 1,800. So add these two together, and we get a total volume of 4,050 inches cubed. All right, the trapezoid, we had a figure just like this with surface area. Remember, with surface area, I said you don't use this because it's not exposed. Remember, volume and surface area, I'm going to keep repeating myself, are a bit different. So with this, you still have to find the area of the trapezoid face. And again, you have to think about it's not sitting on the trapezoid base, so you would have to flip it up. If you were to flip that top piece over so that it was sitting with the trapezoid on the bottom, the height would be 10. So I'm going to find the area of the trapezoid. This top base is 2. The bottom base is 5. So area of a trapezoid is 1/2 times the sum of the bases, 2 plus 5, times the height, which is 2. So 7 times 2 is 14. Half of 14 is 7. So now I'm going to take 7, which is the area of the base, times the 10, which is the height of the prism, and the total volume for the top piece is 70 centimeters cubed. Now I have to work on just finding the volume of the bottom rectangle. So the bottom rectangle has a base of 5 by 10, which is 50, and the bottom rectangle is 3 centimeters high. So 5 by 10 times 3, and the bottom is 150 centimeters cubed. So add your two composite figures together, 150 plus 70, and we have a total volume of 220 centimeters cubed. All right, number 9. Whenever you are given word problems, I would always try to draw out the rectangles so that you kind of have a visual to look at. So example 9 says, what is the maximum number of rectangular boxes, each measuring 2 by 3 by 5, that can be packed into a rectangular packing box measuring 18 by 19 by 35, if all of the smaller boxes are aligned in the same direction? So first, I'm going to draw out the smaller rectangle. So it's a 2 by 3 by 5. Now I'm going to draw out the longer rectangle, and of course these are not by any means drawn to scale. This is 18, 19, and 35. So you are trying to figure out how many of these small ones right here can fit into this large one. So you need to first find the volume of the small one. So 2 times 3, which would be the base, times the height. The small one is 30 inches cubed. The large one, 18 times 19, which is the base, times 35, which is the height, is 11,970 inches cubed. Now, to figure out how many of these small 30-inch cubed boxes can fit into the large box, you would divide the volumes of both. So if I take 11,970 inches cubed and divide it by 30 inches, I would get a total of 399 boxes. All right, our final one. Example 10. If the volume of a cube is 512 centimeters cubed, what is the length of one of its sides? So if you were to take a cube, I'll draw one out real quick, and let's say each measurement was 6. I would take the base, which would be 6 times 6, and then times the height, which is 6, and I would have a total volume of 216 units cubed. So if I wanted to figure out what one of the side lengths was, you would have to take the cube root. And it's a button that looks like the square root key, but it has a 3 in it. So you're going to have to look on your calculators because I'm not there to show you. But just like the regular square root button, you might have to hit the second key or the shift key followed by some other type of button. If the cubed root button does not already have its own button, then it's probably written in another color above one of the other buttons. So you guys might want to spend after this lesson a minute or two trying to figure out where your cubed root button is, because you will have a few questions like this. So if I type in the cubed root of 216, I'm going to get the measurement of 6, which would be the measurements of one of these sides. So your question here with this is saying if the volume of a cube is 512 centimeters cubed, what is the length of one of its sides? So I would have to take the cubed root of 512, which is 8. So then if you go backwards and type in your calculator, if I had a cube with the measurements of 8 by 8, so 8 times 8 times 8 equals 512. So, all right, you guys study this, work through, go back to the notes if you need to. You're having a quiz on Friday, so please go back and really study your notes so that you can do great. And I hope that you guys have a good week, and I'll see you on Monday. Thanks.